Thanks for the invitation. And first time in this series of conference, I'm giving talk. Really pleasure. First time also in this city. Switching gear from terrestrial experiment to extraterrestrial experiment, site and experiment. Let's see how can I justice. Title is, I don't know, this is the correct way of, anyway, powerful GRMHD accretion around black holes. And also, by my simulation, more than 100% energy can be extracted. And for that, magnetic field is very important, apart from general relativity, which is of course very important for this particular work, but only general relativity will not suffice. Magnetic field is playing very important role. I'll show with very basic theory and underlying numerical simulation. Done by my past and present students, Mayank, Rohan, might be sitting somewhere there with different morphology perhaps, but recognizable, and Kaushik. In the title, the terminology is there, black hole. So, what the black hole is, just for every man's convenience. Basically, this is an object which cannot be seen directly. By definition, black, which tells us nothing is reflected. So, to understand existence of a black hole, one has to look its environment. And what is environment? It could be a disk-like structure called accretion disk, and also powerful ejection of matter called jet. Those are the basic features associated with black hole. Seeing that, we can say, okay, possibly there is a black hole sitting. And this is very simplistic way of understanding forming of accretion disk, which is the basic building block of light production to identify black hole. Two force, and this is a resultant force, and forming a spiral path, forming a disk, which is emitting light. More physics speaking, basically equipotential surfaces form from this star supplying matter and black hole having tremendous gravity. They're intersecting, and these lobes form, and accretion disk is this. There's another artist diagram. Such flows are very hot, and as a result, system is ionized, and ionized particles are moving, producing current that produces magnetic field, and that field lines are shown here, which play a very important role. This is the Hubble Space Telescope image producing powerful jet. We'll try to show in next 20 minutes or so how this jet could be formed, and I'll show you that energy associated with the underlying system, jet and the accretion disk, could in principle be more than 100%, and that energy is coming from the black hole's rotation, an interaction between black hole and underlying magnetic field. I'll try to convince you. And this is the underlying space-time, which is non-inertial, general relativistic. Let's try to motivate you with a simple movie. Basically, a torus is sitting here, and black hole is sitting at the center. Torus is supplying matter. How, during supply of matter from the torus to the black hole at the center, how disk forms and current forms, and basically jet generates. See? So basically, this is magnetic field lines form first, and then matter climbing up. Field lines are coming because you have various components, azimuthal component, radial component, and those are magnetic shear components giving twist. And matter is rotating, accretion disk is rotating. As a result, field lines is twisted, as you see here, twisted field lines, and through which matter is ejected. I'll give the physics in detail in a few minutes. So this is basically, and you see disk is forming, and at the central region of the disk where black hole is sitting, around that black hole region, twist is very vigorous, and that produces powerful jet, which I'll try to explain why it is able to produce more than 100% energy, and what is the consequence, what is the physical or astrophysical implication. I'm an astrophysicist, so what is the implication? Finally, I have to understand any theory or numerical calculation in order to understand nature. So let's go back to very basics. What is the, in the first place, energy of the black hole system? So suppose black hole, as I said, powerful gravity sitting here, and everything is being attracted by the black hole. It is coming from infinity. Matter coming from infinity due to black hole's potential energy and converted potential to kinetic heat energy, that process from the inner region of the black hole could produce energy per unit mass about 10 to the power 20, which is even often higher than specific nuclear energy release, a huge energy. In other language, if I supply matter from the infinity of 10% of some limit called critical limit called Eddington energy limit, accretion rate limit, if by that rate matter is supplied from the very inner region of the black hole called R in ISCO. I'll touch upon what is ISCO is, R in is. Energy release is 10 to the power 38 arcs per second. And this 10 to the power 38 arcs per second is at least 5 order of magnitude higher energy that sun produces. So it tells system is having huge reservoir of energy. Forget about the infall of matter, black hole alone, due to its rotation, can be reservoir of energy from this simple formula. A is the black hole's angular momentum per unit mass. If this is 0, this rotational energy is 0. You can check by putting it 0. If it is 1, from the unit system I choose, maximum possible value could be 1. And for that, rotational energy could be 29%. And in CGS unit, if I convert for a black hole of mass 10 solar mass, the energy could be 10 to the 54 arcs. All examples suggest black hole system is a huge reservoir of energy. Question remains, if it's a reservoir, I have a well having lot of water, how to take the water out? There's a big question, how to siphon the energy from the system? That's the question we'll be trying to ask in the next 15 minutes or so. So again, some little basic physics for this community who may not be, all are not expected to be knowing astrophysics. From central force field we know, effective potential for a particle coming from infinity with angular momentum per unit mass L, we know this is the potential, potential per unit mass, potential energy per unit mass. Due to non-inertial nature of the black hole, this extra term comes. Non-inertial nature of the space-time due to presence of black hole, extra term comes. 1 by r cube term comes. Newton's law tells this is the potential, central force field. But due to black hole's presence, extra term comes. In place of one extremum, you have two extrema. And that extrema are determined by the angular momentum on which particle is falling. And as angular momentum keeps decreasing, extrema come closer. At some point they merge. That is the last stable circular orbit. That is the effective inner radius of the accretion disk I was mentioning at the beginning. So that ISCO I was mentioning, R in, energy released from there. So black hole typically is determined by its mass, spin, and so that's why we'll be having interplay between spin of the black hole and magnetic field to understand the processes. Another very important point I must mention before I go into simulation and result is ergosphere radius. So this is black hole. Nothing I'll be targeting inside the black hole. This is black hole event horizon. My entire discussion will be outside event horizon. However, due to presence of the rotation of the black hole, another ellipsoid forms, which disappears if black hole is non-rotating. This ellipsoidal region is called ergosphere region. Ergosphere region is a region where particle cannot be static, and that non-static nature of the particle being here is playing role to siphon energy through magnetic field. That's why I am bringing this here. Suppose a particle come in this region, and you split the particle into two parts. One is captured by the black hole due to strong gravity, and another particle is coming out by some means, or rather scattered off. The guy which is scattered off takes energy from this bath, because this region is influenced by the black hole rotation, something called frame dragging. And the guy which is coming out from this region is taking energy from the black hole with extra energy than on which it is reaching here. And the guy which is captured, which is lost, which is negative reflection. As a result, total reflection and transmission coefficient, which is 1, conservation of energy, this is negative. Transmission could be more than 1. That's the point by which extra energy particle is gaining from the bath. That's called basically Penrose process. And that Penrose process can give energy efficiency up to 21%. So all these argue that system is very much susceptible to give you energy, but question remains, why, how to tap the energy? System is susceptible, but how to tap the energy? Bait is magnetic field. I'll show magnetic field lines is anchoring in the system that helps to take the energy from the bath and ejecting to the surrounding environment. How is it possible? I'll show you. So now field lines is introduced. This is the torus or accretion disk I was mentioning. Field lines are anchored, and this is rotating, as I said. Ergo region, the ellipsoid region, which is always rotating. Or outside region, accretion disk, which is also rotating. Either of the situations is giving rotation, and due to rotation, field lines are twisted. And this, due to twisted field lines, the two possibilities are happening. Outer region, when twist is due to accretion disk, those are not necessarily general relativistic, not necessarily non-inertial. Those are giving some process and giving wind production called Blandford and Payne process, need not be general relativistic. The guy, inner region, twisted due to that oval shape region. Inner region is twisted due to inner magnetic field lines are twisted due to this oval shape region. And those are the greenish line are always twisting, never it stops, because inner region always rotating. And those are necessarily general relativistic, called Blandford-Znaeck effect, which is basically magnetized Penrose process. So if I look at the movie, you see, this is a torus. Initially, you see, inner region is rotating, and that is why magnetic fields are twisted, and you see that green lines are the twisted field lines. But with time, disk forms. Initially, there is no disk. With time, disk forms. Outer region also starts revolving. Due to disk rotation, outer regions also started ejecting matter by outflow. So two possibilities are there. Inner region, green lines, very powerful ergospheric-based energy extraction, and outer region, accretion disk is rotating, that also produce powerful energy, powerful outflow. And those all together is able to produce very strong outflow, and collimated outflow, often called jet, and those are able to extract energy, and which often could be more than 100%. So I am talking about black hole rotation, that means general relativity, which is necessarily required for part of the situations. I'm talking about magnetic field. So both are important, but then question comes naturally, natural system, how strong magnetic field is there, such that strong field which I require as my ingredient to produce this powerful jet, how strong magnetic field could be in natural system? Yes, it is available. Some black hole system called Cygnus X1, from its observation, one can show footprint of the outflow can have magnetic field about million Gauss. And million Gauss field is not difficult to understand here from the flux freezing idea, that if sun-like star is supplying magnetic flux with field 1 Gauss of size say 10 to the power 5 kilometer. That flux, when it comes close to the black hole, size is very small. 1 Gauss from the frozen flux could be million Gauss easily. And if that same result I'm extrapolating to supermassive black hole, there's a simple power law, scaling law. Magnetic field scales inversely with mass. Same million Gauss could be 10 to 100 Gauss, which are interpreted indeed from Fermi-Blazer observation. So, field I require to produce powerful jet to siphon energy more than 100% is available in the nature. So, with this I'll go for detailed simulation. Two simulation codes I consider. One is black hole accretion code, VAC, another is HARMPI or HAMR. This is primarily 3D and this is primarily 2D for the present purpose. This also has 3D version. And with both the codes, I am verifying my theory and observational understanding. And two further classifications. One is magnetically arrested disk, another is standard and normal evolution. Just remember, MAD means strong accumulation of the matter, kind of magnetic potential is determining that. And SANE means less accumulation of matter. Both are determined. Distinction is coming due to magnetic vector potentials. They are different. And those are the various simulation setup. Parameters as black hole spin, 0 spin to very high spin I consider. Plasma beta, very high to low plasma beta considered. And resolutions are considered like that. 3D HAMR is considered to be with higher resolution than 2D. And the torus I was showing to start with in various movies are having inner edge 20 gravitational radius, and maximization of the torus is about 41 gravitational radius. With that, I'll start with a movie. So black hole is sitting here. Due to black hole's attraction, matter is falling in. And as matter is falling in, that means strong radial velocity is there, which is called advection. So advection has to be there to form matter coming here. And due to matter coming, due to frozen flux, field is also dragged in. And continuous high magnetic field and flux is advected. As a result, magnetic wall forms. And that magnetic wall, I'll show you, is responsible to eject matter. And three scenarios. Here, slow accumulation of matter, SANE, with 0 spin. Here, high accumulation of matter with still 0 spin. But here, high accumulation of matter, MAD, but high spin. This is a comparison, how spin and magnetic field together play the role. See, here, always it is wedge shape, almost. These two fellows, high spin, low spin, and it has much more stronger eruption compared to this. And these eruptions are basically flash of powerful energy ejection, which often could be more than 100% due to conversion of magnetic interplay between magnetic field and spin, and extra energy, which is exceeding 100% extraction, efficiency becomes more than 1 because black hole is giving extra power. See this fellow, we have huge flare now. Top one, no flare. Both are flare, but here huge flare. Apart from strong magnetic field, you have high rotation. Together, plays very powerful system to extract energy. So basically, this slide I borrowed from Ramesh Narayan of Harvard. So basically, this is the scaling law. Power is proportional to magnetic flux square, black hole spin square. If one of them is 0, at least from this process, there is no extraction of energy. Other extraction of energy is possible. Non-general relativistic extraction is possible. But for this process called Blandford-Znaeck mechanism and underlying magnetically arrested disk, MAD, magnetically arrested disk, this process will not work. And so this is basically a variant of magnetic Penrose process called Blandford-Znaeck process. Another movie, Rohan prepared. I see now he's sitting here. So top one, low magnetic field, high magnetic field. You see, high magnetic field is much more vigorous. Arrows are basically indicating direction of the fluid. And that bottom two are for two different spin, low spin, high spin. Again, high spin, directly you are seeing that much more virulent or vigorous than low spin. So that gives you how spin and magnetic field together play very interesting role to control the outflow. So this is 3D. So far I had shown only 2D, now 3D. So this is basically low magnetic field system, high plasma beta, high magnetic field system. Initially plasma beta low, but importantly, 3-dimension and high magnetic field together make system also asymmetric. See here, quite symmetric flow, but here extreme asymmetry comes. So strong field and 3D together makes it very asymmetric, and 3D is presumably in majority cases most realistic. So this is the quick geometry. So SANE, which is low magnetic field accumulation, is mostly quasi-Keplerian. Aspect ratio is small, thinner. System is thin geometrically. And system is rotationally dominated compared to radial flow. Strong magnetic accumulation, MAD, which is advective-like, matter is strongly falling in. And you see, this is far away radially dominated. But then, due to strong radial motion, magnetic field is accumulated in an inner region. As a result, radial motion is stopped. And azimuthal motion starts happening. And then matter is kicked out. A opposite radial force happens. See sign change. And it is geometrically thick because matter is continuously accumulating, and field is piling up, and matter is also piled up. And as a result, H by R is very large. Aspect ratio is very large. So geometrically different. So the spectrum, because when I talk about accretion disk, any object in the universe, even here, it is a light which helps us to see something. So spectrum plays very important role. So this is a typically spectrum. So this is basically a synchrotron peak, inverse Comptonization of the synchrotron, Bremsstrahlung, and this is MAD, this is SANE, high spin, and the temperature profile. I don't have time. So quick application. How much time do I have? 2 minutes speaking time, right? Quick application, one of the sources called ultraluminous X-ray source, which is known to produce hard X-ray, and hard X-ray production can be explained if system has limited upper limit of accretion rate, which only help in producing hard X-ray, so that energy release cannot be by matter. It has to have something extra. We bet it could be magnetic energy which is coming, and luminosity is 10 to the power 40 arcs per second. And this is the spectrum, and then we are computing power from the simulation I showed, and this is the efficiency, supply, net supply of the energy, C is 1, net energy produced and the difference, which is outflowing energy and corresponding efficiency. And we show that MAD and SANE with high spin only is able to explain the ULX power I just mentioned from the observational data. To explain to the 40 arcs per second, you need high spin. Low spin will not give. Zero spin does not give any power. So spin is very important role, black hole spin. But if I go for realistic 3D, previous one is 2D, and energy extraction could be more than 1000%. But in this idealistic 2D case, but if I go for 3D, energy extraction could be reduced to 250%, and still, which is more than 100, and very promising. And we are able to explain hard ULX if you introduce massive slightly massive black hole. But again, you need high spin. Low spin does not give any, does not help us to explain the production. So basically, in previous 25 minutes, I was trying to target a very enigmatic astrophysical phenomenon. Okay, now it is no longer enigmatic, but well-talked astrophysical phenomenon called astrophysical jet, which is often visible in various astrophysical sites, matter is coming out with very powerful collimated fashion. And from the stellar mass black hole to supermassive black hole, general relativity seems indispensable to explain them. So black hole and its presence at the center of the accretion disk in general relativity is a very powerful energy reservoir. I tried to convince you. Tapping energy is a question. So I looked at the energy extraction from spinning black hole in the presence of magnetic field. Black hole could be susceptible to give you energy. To get energy extracted, you have to have magnetic field. And our numerical simulations says that this indeed, the theory proposed by Penrose and later on modified by Blanford and Znaek is indeed possible by numerical simulation. And our application to explain ultraluminous excess source in hard state, and power cannot be explained unless I consider black hole spin magnetic field both, and 3D power is smaller than 2D. So bottom line is that GR, advection, magnetic field, all three together require to explain most powerful energy extraction or energy as we observe in the universe. Thank you very much.
Thank you, Bani brother, for a powerful and exotic presentation. So now we have 4 minutes. The priority is students. So you, first students, then...
Abhishek, my favorite student in any case in IISc.
Yeah, thank you, sir, for a nice talk. So I have one question. So you showed us that the matter that is extracted, it goes in a cone shape, perpendicular to the accretion disk. So why does not it go sideways?
In principle, yes. So basically, 3 magnetic field components are there: Br, B phi, Bz. The fellow which is B phi Bz, which is doing this. Okay. The fellow which is Br B phi, which is doing this. Okay. So, but as because here primarily poloidal field, which is targeted, and actually system has to be such that poloidal field is most strong. So poloidal field dominated system will kick the matter in the vertical direction.
Okay, and one more last question. So there is a cone-like shape.
Cone?
So, yeah, means
yes.
So do we have some limit, like at what maximum angle the matter is ejected?
Yes. So you're saying how broad it could be, small size, right? Fantastic, very good question. So actually it turns out that if field is strong, then wall also forms further away. Accumulation of matter will be, accumulation of flux will be further away. Strong field, high spin could actually make it bigger. Even counter-rotating black hole, retrograde orbit is possible to be happening here, whose ISCO is further away, it could be further bigger. So depending on the black hole spin and magnetic field, we can determine the size.
Okay, thank you.
We can take second question. Yes.
Thank you for the another my student, ex-student. Okay.
Yeah. So I have a few questions. Chronologically, first one is, I do not understand the following question is it dynamic process, this extraction of spin? Because extract the energy, then the spin will decay. So if, it will decay down, the spin will go smaller and smaller, and hence expected that the energy extraction will be smaller and smaller. Now, if you say it's a steady process, then steadily the energy extraction will be happening and spin will go down. If you, as you showed in your movies, that it can be a transient phenomena, and then also the spin will go down, but transiently. So is it a dynamical process, or is it a steady state process, or the steady state is remained by the influx of matter? That's one question.
Yeah, I would say it is combination of both. As you correctly noticed, matter is coming and spin energy is extracted, and black hole spin goes down and energy is extracted. Matter is ejected out, it becomes quiet, and then accretion forms, and matter continuously goes all the way to the black hole for some time. Again, decayed spin will gain the spin, and again phase set of matter comes continuously. At some point, significant field generates again, and again wall forms, again matter is ejected. So it is transient, and in and out this happens. So spin loses, black hole loses spin, gaining spin.
Another question.
No, only one question, please. Yes, you.
Yeah, Prakash actually raised hand at the very beginning.
That's fine. We should give chance to the students first, so that's why. Thank you very much, Bani, for very nice talk. I have very naive question. The question is, do you need black hole to do this, or can you use a neutron star with high magnetic field?
Very nice question again. So, for most powerful ejection mechanism, I would say black hole is necessary because ISCO comes very close to the event horizon. ISCO for maximal spinning black hole is same as black hole event horizon. For neutron star, even I choose small size 10 kilometer, ISCO is quite away. And most gravity is coming from the black hole singularity, real singularity. So closer the ISCO, so stronger the possibility of extraction energy. So yeah, possible, but less energy.
Thank you.
Okay, last question.
Yeah, thank you for a nice talk.
Bendu had a question.
Yeah. Okay.
Yeah, please.
Yeah, I was just wondering, what equations are you solving actually when you talk about GRMHD equations?
Yeah, so basically, I don't think if I have, so basically, you know Navier-Stokes equation with magnetic field?
Yes.
That's non-inertial version.
Okay.
Basically, general relativistic Navier-Stokes equation with magnetic field, along with supplemental equation, magnetic induction equation. Basically, Einstein-Maxwell coupled equation. Let me see if I have a backup slide, just to show you quickly the equation. No, I don't have. I have only this. I borrowed from the review article of Naresh Dadhich, but still it is not a complete equation. It's an expression for efficiency. No, but basically, yeah, GR version of Navier-Stokes and Maxwell's equation.
And what is the geometry you are working on? I mean, it's
Geometry.
yeah, it's a full toroidal or torus or what kind of?
So
geometry?
because black hole is spherical object, whether rotating or not, most suitable geometry is spherical polar. But again, due to black hole's presence, event horizon forms, which is a coordinate singularity. Often simulation faces problem to avoid that problem. So we often go for different coordinate system for simulation purpose, Cartesian coordinate, which is more like Cartesian, not real Cartesian, Cartesian-like to avoid singularity. So those are the technical part, but generally spherical polar coordinate.
One last quick question, maybe.
In your 2D simulation, I see this reconnection of the field lines. This magnetic islands kinds of structures are forming. So what is the role of these reconnection in the jets? Means you study these?
Okay, first of all, although you see some reconnection type effect, my result is without any explicit viscosity. So any reconnection you find is due to numerical viscosity. Now, point is that formation of jet primarily is happening due to magnetic wall forms. So reconnection has some effect which is due to numerical viscosity, but in the reality, when strong magnetic field, remember MAD, I said magnetic elastic disk, reconnection is subdominant compared to large-scale magnetic effect which is ejecting matter out. Reconnection is useful, other case SANE, which is having also magnetostal instability in the region. So where reconnection is there and can produce weak jet or wind.
Thank you.